Welcome to The Explainer. Today, we're diving into a skill that's an absolute game changer for any data scientist looking to level up into ML engineering. You know what I'm talking about? Taking those models we build in our messy notebooks and turning them into clean, reliable, production-ready assets. This is at the very heart of MLOps, so let's get right into it.
So picture this. You've been grinding away in a Jupyter notebook, and you finally built a model that works. It's awesome, but let's be honest with ourselves for a second. Is that code really ready for the real world? Can someone else, or even you in 6 months, easily reproduce it? Is it totally bug-free, simple to deploy? Yeah, for most of us, the answer is a big fat probably not.
And that leads to all those classic modeling nightmares, right? The stuff that keeps us up at night, like accidentally leaking data from your test set into your training, which completely messes up your results, or, applying transformations one way during training and another way during testing. And don't even get me started on the absolute slog of tuning hyperparameters by hand. It's a mess. And today, we're going to clean it all up. Okay, so here's our game plan for today. First, we'll go from mess to masterpiece. We'll break down what modeling pipelines actually are. Then we'll get our hands dirty and build one. After that, we'll look at optimizing it with grid search. And finally, we'll lock in our best model. It's basically the blueprint for taking that notebook prototype and turning it into a pro-level asset. So let's start with part one. What are modeling pipelines? This is, without a doubt, the elegant solution to all those messy workflows we just talked about. So what is a pipeline really? Well, think of it like an assembly line for your machine learning model. It takes all your different steps, cleaning the data, feature engineering, training the model, and chains them all together into one single neat package. The beauty of this is that it guarantees everything happens in the exact same order every single time. No more mistakes, no more inconsistencies. Now, it's important to note that the word pipeline can mean a few different things. You've got these huge data pipelines for grabbing and cleaning data, and then you have orchestration tools like Airflow that manage entire complex workflows. But for us today, we're zooming in on the model pipeline. This is all about preparing data specifically for a model and then applying that model. And we're going to be using Scikit-learn, which is just fantastic for this. I mean, look at this. The difference is like night and day. Without a pipeline, you're just inviting trouble. Data leakage is almost inevitable. Your steps get all jumbled up. But with a pipeline, boom. You prevent data leakage because the pipeline handles the data splits correctly. You get guaranteed consistency, and things that used to be a huge pain, like cross-validation, so much simpler. Manual tuning becomes streamlined. It really is a total workflow transformation.
Okay, that's enough of the what and why. Let's dive into the how. It's time to build our very first pipeline. Let's get hands-on with the code.
All right, so here's a super common problem you're going to run into immediately. Your data is a mix of stuff, right? You've got numerical columns that you need to scale, and you've got categorical columns with text that you need to one-hot encode. How on earth do you tell a single pipeline to do different things to different columns? How do you manage that complexity?
The magic wand here is ColumnTransformer. Seriously, this thing is amazing. The best way to think about it is like a traffic cop for your data columns. As you can see in the code, you basically just tell it, hey, for these numeric columns, apply this numeric transformer, and for these categorical columns, apply this other categorical transformer. It then neatly applies the right steps to the right columns. It's an incredibly clean and powerful way to handle mixed data types.
Okay, next up, another classic headache. You're running experiments, maybe trying out different model parameters, and your pre-processing steps, they can take a while. So you find yourself just sitting there, waiting and waiting, as the same exact pre-processing runs over and over and over again. There has to be a better way, right? How can we speed this up? And there is. Check this out. The secret is this little memory parameter right here in the pipeline constructor. By giving it a directory, a cache, you're telling Scikit-learn, hey, before you run a step, check if you've done this exact calculation before. If you have, just use the saved result. It's called caching. And when you're doing something like a big hyperparameter search, this can literally save you hours of computation time. It's a total game changer for your workflow speed.
So we've built a pipeline, which is awesome, but now we've got to make it the best pipeline it can be. This is where we get into optimizing with grid search. And this is about finding the best model systematically. This is a core MLOps skill.
So the big question is, now that everything is nicely wrapped up in this pipeline object, how do you actually tune the parameters inside it? How do you, for example, change the regularization strength of your logistic regression model?
or maybe even tweak a setting in one of your pre-processing steps.
The trick, and this is really important, is this special double underscore notation. See that? Classifier underscore underscore C. What that's saying is, go find the step in the pipeline that I named classifier, and then inside that step, find the parameter named C. You just use the name of the step, 2 underscores, and the name of the parameter. This lets you reach into any part of your pipeline and define a range of values to test. It's super, super powerful.
Okay, but as we start searching for these best parameters, there's a huge trap we need to avoid. How do we know we're not just getting lucky? Finding parameters that work great on our specific training set, but will completely fail on new data. We need a way to get a reliable result we can actually trust. And that is exactly why cross-validation is so essential. The idea behind 5-fold cross-validation is actually pretty simple, but it's brilliant. First, you take your training data and you split it into 5 equal chunks, or folds. Then you train your model on 4 of those chunks and you validate it on the one piece that was left out. You write down the score, then you do it again, but this time you hold out a different fold for validation. You repeat this 5 times in total, so each fold gets to be the validation set once. Finally, you just average those 5 scores together. What you get is a much, much more stable and trustworthy estimate of your model's real-world performance. And this right here, this is where everything we've talked about comes together perfectly. Scikit-learn's GridSearchCV is just chef's kiss. You just hand it 3 things: your pipeline, that param grade we defined with the double underscore notation, and you tell it how to do cross-validation. In this case, CV equals 5 means 5-fold. Then you just call .fit and it does all the heavy lifting for you. It will systematically test every single parameter combination using cross-validation for each one to find the absolute best setup. It's automation at its finest.
All right, the grid search has done its job. It's churned through all the options and found the winner. Now for the best part, finalizing your best model. We're going from search to solution.
So this brings up a really important question. Think about it. During that whole cross-validation process, we were always holding back a piece of the data for validation, right? So to get the absolute most powerful model we can, shouldn't we retrain it one last time using all of our training data? And here's the best part. You don't have to. Scikit-learn is one step ahead of you. By default, after GridSearchCV figures out the best set of parameters, it automatically does that final step for you. It retrains the best version of your pipeline on the entire training set. So when you access that .best_estimator_ attribute, you're not just getting the winning parameters, you're getting the final, fully trained, ready-to-deploy model. It's brilliant. And that really brings us to this idea. The final model embodies the culmination of your exploratory work, positioning it well for effective deployment. I love that because it's so true. That best_estimator project isn't just a piece of code anymore. It's a professional asset. It represents all your exploration, your systematic tuning, and your robust validation. It's something you can confidently hand off for deployment. So, there you have it. Your production-ready pipeline is built. It's clean, it's reproducible, it's optimized. But what's next? Well, now you have to think about how you're going to deploy it, how you'll monitor its performance in the real world, and how you manage its entire lifecycle. And that's the next big step on your MLOps journey. Thanks so much for tuning in.